We are the paradoxical ape. Bipedal, naked, large-brained, long the master of fire, tools, and language, but still trying to understand ourselves. Aware that death is inevitable, yet filled with optimism. We grow up slowly. We hand down knowledge. We empathize and deceive. We shape the future from our shared understanding of the past. CARTA brings together experts from diverse disciplines to exchange insights on who we are and how we got here. An exploration made possible by the generosity of humans like you.
Thanks very much for the opportunity to come and talk with you today. I'm going to speak about our work on how crows and other birds recognize and respond to their dead. The message is fairly simple from what we know at this point. I think that it mainly is an opportunity for them to learn about sources of death and places to avoid, and perhaps other objects in the environment to avoid. So I see it as a real arena for learning. Before I get into the crows, I wanted to step back to the mammals for just a second and relate quite an interesting observation I had in Yellowstone National Park about 4 years ago to this day. And at this point, we were with a group of students looking at a wolf kill, trying to assess the landscape that might have contributed to this death. And it was an old female that had died. She'd been killed about 2 weeks earlier. And the death scene was one of a large cleft boulder. The female had backed into that. It was a bison that had been killed by a pack of wolves. And we were measuring the aspects of the terrain and the situation. There was a lot of still blood stained on the rock and the bones of the dead female bison on the ground. And as we were busying ourselves, we heard a roar of hooves come over the ridge, and the whole herd of about 3 dozen bison displaced us from that scene. And we felt pretty bad for having been there and interrupted this situation. But the thing that was impressive was that these bison, after they pushed us away, they all smelled the bones, much as we heard with other mammals, and then each one individually walked through this cleft in the rock, right where the female had been killed, and passed through, and then went on their way. They were there for about an hour in total. And that's very different than we see with the response to when a crow finds a dead animal. So what you see in this video are the responses of crows to finding a dead bird that we placed on the ground right below that telephone pole. They come in, they're very noisy, they gather, and they might last for 15 or 20 minutes before they move on out of the area. And this is a widespread response that's been seen in other members of this family, the Corvidae. That includes things like magpies, which have been seen to even bring tufts of grass into a dead magpie, or scrub jays. There's been a lot of work on scrub jays just north of us here, and also ravens gathering around the dead. So let me introduce you to this family of birds briefly. They're birds that are familiar to most of us. They live close by with us. They include the ravens and crows, magpies, jays, nutcrackers. And they live around the world in all the continents except Antarctica. And almost all of these species have had some sort of interaction, as I described with the crows, to finding the dead. So some aspects of this group, they're long-lived, they're typically social, they have long-lasting partnerships with their mates and sometimes extended family groups. They have rather large brains for their body size. On this graph, these show the average relationships between body size on the x-axis and brain size on the y-axis for things like fish. And here's the average bird line. And then you'll see that the dots for the various corvids are well above the bird line, more on the mammal line, and even some like the American crow that I study right on the primate line. So these are really more like small flying monkeys than they are birds. Their brains are quite complex. We know now in the last several decades that they include places in the brain that are analogous and also homologous to ours. For example, the hippocampus is a homologous structure, and the amygdala is at least an analogous structure. They have a large forebrain, all this area here. There's a striatum, but a large forebrain where more complex sorts of sensory information might be combined and considered. And they have important connections between this forebrain and the thalamus back up to the forebrain that allows these animals to reconsider actions and shape them before they act upon that information. So the typical response is to get some information in, maybe from the eye, process it in the forebrain, and send a response down the spinal cord to the muscles to do something. But they don't have to always do that because of a connection here that allows that information to go back to the forebrain and be adjusted. That's how they, for example, learn different vocalizations. So with an animal like that, long-lived, social, and quite cognitively nimble, there are many reasons why they might attend their dead, as we discussed just with Dora's presentation. So they may be looking at a social opportunity, a vacant territory, a potential mate, for example. They may be looking to learn about danger. They may be looking at other aspects of that scene to learn what caused the death, what sort of expectation in the future that area may hold for danger and things like that. They may also be grieving and mourning a lost member of their family. Or, as I said, since these animals mate for life, they might have been with the same individual that's dead now for 20 or 30 years and might have a profound relationship and interaction with that animal after it's lost. So we have tried to investigate this response by doing experiments. And what we do is we basically prepare taxidermy mounts of individual crows and have them in kind of a dead status, and then we place those out and see the response of wild birds to those mounts. And this is a general description, basically, of what we do. There's some sort of a conditioning phase where we get animals used to coming to an area. Then we present them with some stimulus. That could be a dead crow or a hawk, for example, just to see the response. And then we measure their response after they've encountered that. And during this time, we've been feeding them at a spot, so we know they reliably come in. They're using that spot to gain food, and we can look for a change in their behavior, maybe how long it takes for them to approach that food after they've seen a dead bird there. So what we found, and this is work, I should say, that my PhD student, Kaylee Swift, and I have been engaged in, and Kaylee's continuing this work now, but these are some of the early findings that she discovered. First off, in terms of how many gatherings occur around these dead crows, about 60% of all the crows we put out had a large mob form around them. And that's similar to what you would see if a hawk was present, which is a known danger. And it's not as often as you would see if a hawk had a dead crow in its grip, for example. That almost always elicits this sort of response. So from this, comparing to more controlled situations where just a person is there feeding or just food is provided, suggests that this is some sort of response to danger for sure. And we know that the individuals are learning something about being in this dangerous place because their approach to the food is quite different after a danger has been seen versus not been seen. So here you just see the amount of time pre and post exposure to a stimulus. In this case, the stimulus is just food or a person, nothing dangerous, no difference. And if the stimulus is a hawk or a dead crow, much longer time to approach that food after seeing that. And this kind of narrows that response because actually in some cases the birds refused to come down to food at a place they had seen a dead crow for up to 6 to 8 weeks. And this is different also depending upon whether it's a crow or a pigeon that they see. So they're very sensitive to the type of stimulus. They avoid places after seeing a dead crow, even though they had been feeding there before. But if a dead pigeon is placed there, there's no real response, no difference. And also, crows do this, and not all birds do this. So we just controlled this by looking at the response of pigeons as well as crows to this sort of presentation. And when pigeons see a place they've been fed at that now has a dead pigeon at it, they continue to feed there afterwards like nothing had happened. I suspect turkeys, we've been seeing some turkey videos of turkeys walking around a dead cat today, and I suspect they act like pigeons in this respect. But crows clearly increase their hesitancy to approach a spot after they've seen a dead animal there. And this is a pretty nuanced response as well. So what we see in this graph is that the response to an adult crow that's dead versus a juvenile crow that's dead over here is different. And that's especially different during the breeding season. So when you find a dead juvenile crow in the breeding season, which is a fairly common response, a lot of young birds die. The adult crows and other crows in the area don't pay much attention to that. They only scold and form a mob about a third of the time. Likewise, during the breeding season, if an adult is found, scolding and mobbing is not as common as it is during the non-breeding season. So this sort of nuanced response to me suggests that this sort of behavior is triggered more by an ecological or more of a social or ecological factor than it is perhaps something like grieving or mourning the loss of this individual. In fact, I would expect the exact opposite if they were really considering, for example, a lost young bird of their own, their sibling or their offspring or their mate. You would expect those responses to be especially strong during the breeding season, for example, and especially strong among adult birds. So we've tried to understand where in the brain the crow is processing this information and using that to help explain a little bit more about why they're doing this sort of thing. And let me explain our procedure to you a little bit here in this slide. We're doing PET imaging of live crows as they view various sorts of dangerous stimuli, a hawk, a person that had just captured them, or a person holding a dead crow, for example. And what we do, shown up here at the top, is we capture our birds in the wild. We wear a mask when we capture them so that they learn a particular face associated with that dangerous experience being captured in the wild. We capture them with a net gun that goes off with a blast and pins them to the ground. It's a pretty scary thing for a bird. And we don't want them to associate that with us when we see them later, and we want to be able to have anybody take on the role of that dangerous person by putting on this mask. So we wear a mask when we catch them. We then bring the birds into captivity and care for them wearing a different mask. So we have one person that's good here caring for the birds, and one person that's bad that has captured the bird. And we keep the birds for about a month. And during this time, we bring them into a smaller cage shown in the middle diagram here, where they are acclimated overnight, and then the next morning we perform a procedure upon them. And that procedure is simply to catch the bird out of the cage, inject it with a glucose mimic that we use as a tracer to indicate where synaptic activity, where nerve cells are actively communicating with one another. And we then put them back in that cage after they've been given the shot of glucose in their belly. And then we show them something. We let them, while they're awake, look out and observe perhaps just a person in the room that they'd never seen. They could observe the person that caught them, or the person that cared for them, or a person holding a dead crow, or a hawk, or nothing at all. And then during that 20 minutes or so, we continue to let them see that person on and off. And we then anesthetize them. And this tracer with the PET imaging allows us to basically step back in time while they're anesthetized and see where in the brain that tracer has accumulated during the time when they were actually looking at that stimulus we gave them. So this way we can keep them still, get a nice image, and see what's going on in their brain, then wake them up, let them rest for a day, let the tracer, the radioactive tracer, clear, and they can be released back to the wild. So for example, here's what a crow would see if it was sitting in our cage, metabolizing that glucose we gave it, and looking out and seeing a person it had never seen before holding a dead crow. The images we get of their brain are striking. They show relative activity by how bright the areas are here. This is the the glucose fluorescing, basically, in the tomography. And what you see here are bright spots on either hemisphere of the brain, which are the intopallium of the bird. That's the visual processing center of a bird's brain, assessing information coming from the two eyes here. I'm going to show you a set of graphs that look somewhat like this, figures that basically show MRIs in gray to show you the structure of the bird's brain, and then the red areas indicate what parts of the brain were most activated in a given set of birds that saw one thing versus a set of birds that saw something quite different. And in this case, this shows the part of the brain, and this is the front part of the bird's brain that's activated when they saw a person in the room versus nobody else in the room. So any kind of person in this case. There's a lot of higher order processing occurring in the forebrain of these birds as they consider that person, and also in the striatum as they possibly are making connections between that person and something that it had previously done. Now, if we look at them in response to basically how they see particular people, what we have on the top panel here is the response of birds when they looked out and they saw the person that had previously captured them, so a dangerous person. And they're recalling at this point something about that person. They already know that he was dangerous, and now what we see activated most clearly, in addition to that frontal area that I showed previously, is their amygdala. So they're basically responding like other vertebrates do, with a strong response on the right hemisphere of their brain in the amygdala region that indicates they're responding to a known danger, a learned danger, I should say. In contrast, when they see a person that they've never seen before and they're learning about that person's behavior because it's holding a dead crow, what is activated most strongly is the hippocampus in the bird. So what we interpret is going on here is that these birds are acquiring information. They're learning about this dangerous person by its association with a dead crow. And in this case, they're recalling something already learned. We know something about the way information proceeds from the eyes up to the bird's brain. And I just show you this diagram to point out the complexity with which this information travels from the retina up through the basal ganglia and into the forebrain. And it's a rather simple picture, actually, when they're looking at a person that they've learned to be threatening, as compared to the situation when they're first assessing somebody that's potentially dangerous by, in fact, holding this dead crow. So here the hippocampus is involved, as well as the forebrain and the visual processing centers. And in this case, it's mainly the forebrain and the visual processing centers interacting. So all of these field experiments and laboratory experiments basically point me to one conclusion. When we show a crow, a dead crow that's not a familiar individual, that they're responding and learning about that situation, perhaps the person associated with it or the place associated with that death. Quite clear, I think, in this respect to me. But what else could we be missing? And to me, this is the more interesting part of the work that we basically, I can only tell you, I don't know. But I hope to find out at some point. But this is a pair of ravens interacting with one another. They form very close relationships, and surely I would guess we would see differences in the brain activity of a bird after it had lost its mate than if it just encounters a dead bird that it doesn't know personally. But we haven't done that experiment. It's something that could be done, but ethically is difficult to do. There are other things that suggest there may be a lot more going on than just learning about a site, and these are more anecdotal observations. I mentioned earlier that when magpies come into their dead, they've been observed to carry grass. And maybe that's just the nesting material that they were carrying when they encountered that, or maybe it was something more purposeful. So, for example, in crows, this picture shows one that was found that was surrounded by these sticks. There were no trees around. There was nothing where these sticks could have just been there incidentally. Maybe a human put them there, or perhaps the crow had come in and put those sticks around this dead crow. We don't know, but I have several observations like this from people. And then finally, just a week ago, a woman sent me this image, which she took on the Michigan State University campus. And what you see here is a crow that is looking at a dead crow. The dead crow was only recently died. The woman suggested it might have hit a window or something by the looks of it. And this bird flew in, totally silent, brought this piece of tin foil in its bill and set it down in front of the dead crow. And it stood there for 20 minutes watching this. I have no idea if these are a mated pair or if, again, this was anything other than incidental, but it's curious to me that they didn't scold, this bird didn't scold and didn't attract a crowd in like we regularly see. So I think there's much more going on here than we know, and it will take much more sophisticated experiments to get at them, which hopefully we'll do in the future. With that, I would thank you very much for your attention.